All right, so given what we know about circles, let's go ahead and try an example that's a little bit more complex. And this one says we want to find the standard form of an equation of a circle with a center at 6, -3, and that contains the point 4, 1. Well, what are we really saying? We have this function that is this equation that represents a circle, and we know where the center is. It's at 6, -3. I'll just plot in what looks like about a 6, -3 point right about here. All right, so this is our center, 6, -3. And we're saying that somewhere on this circle it contains the point 4, 1. So if we have this circle, let's find the point 4, 1. So let's say this is about 4, 1 right here. So we have this point x and y is equal to 4 and 1 on the circle. Now you don't have to graph this out every time, but sometimes it helps to see it done out. So what does that mean to us? Well, it means that we've got this circle, and this circle is such that if we were to draw a line through it, oops, didn't want those last two things. If we were to draw the circle passing through it, what would happen is that this circle would contain the point 4, 1. Let me move this up a little bit here. Our circle would contain the point 4, 1. See, the center is not on the circle, but the point 4, 1 sure is. So what we would do is we would take that to be our coordinate point somewhere on the circle. So what two things do we need to make up the equation of a circle? To make up the equation of a circle, we need two things. A, we need a center. And we've got that. Our center, HK, is at the point 6, -3. No problem there. H is equal to 6. K is equal to -3. The problem that we have is the radius, because that's the other thing that we need, is the radius of our circle. Well, what is this radius? R. Well, this is where we need to do a little bit of extra work right here. That radius is actually the distance between our 2 points here at 6, -3 for the center of the circle and 4, 1 for the edge of the circle. So we need to use our distance formula. R, the radius, would equal to the square root of the difference in our x values. So it looks like 4 minus 6 squared plus the difference in our y values, which is 1 minus -3 quantity squared. Well, let's work out the numbers right here. This is going to be the square root of -2 squared plus the square root of 4. Plus 4 squared, not the square root of it, because we're taking the square root after we take our squares. So r is equal to the square root of 4 plus 16, which is to say the square root of 20. Right? So our radius is 20, square root of 20. That means that r squared itself will be equal to 20. Right? So if we know that, then we could say that our equation in standard form, using our model above, is going to be x minus 6 squared, that's our h, plus y minus -3, so that's y plus 3 squared, that's our k, equals r squared, which we just found was equal to 20. So this would be the equation we were looking for. And so we're done.